So welcome everyone to Transactions and Calls Explained. My name is Pavel and I'll be your host for today. So who this workshop is for? This workshop is for people who have heard of Ethereum and are interested in how Ethereum works. This is more from a developer's perspective, so it might get a bit technical, but I'll try to make it as easy to understand as possible. So who I am? My name is Pavel. I'm a software engineer by profession. I've authored blockchain development videos and tutorials. I've also created and led the CryptoChicks Hatchery blockchain program, where we help educate entrepreneurs looking to start a decentralized business. I also enjoy teaching blockchain development topics worldwide. And that's my headshot. I'll be going over what a transaction is, how a transaction can be used, as well as what a call is and how a call can be used and what the differences between a call and a transaction are. I'll also be using calls and transactions in order to interact with smart contracts, and you'll see a demonstration of that a bit later. So an overview of the three topics. Today we'll be covering mostly about the architectural and the smart contract aspects. We won't be touching the coding aspect. That is for, I guess, a later workshop in the next hour. So why are transactions important? Well, transactions allow you to change the state of the Ethereum network. So some examples are to send Ether and to execute code on the Ethereum network. Now that we know why transactions are important, what is a transaction specifically? Well, imagine you are a computer, but more specifically, you are an address. This address is assigned a value of Ether according to the Ethereum network, the Ethereum blockchain network. Now, how do I interact with you, the address, and the Ethereum network? Well, we use what is called a transaction. That bit of code right there. Let's zoom in a bit. Whoa, that's a lot of information, but don't worry, we'll break it down one step at a time, starting from the nonce. Now, what is a transaction nonce value? Well, transaction nonce value is the number of transactions the sender has sent before this transaction. That's a lot of words. To put it simply, it's that looking previously, we have a nonce of 5. So the sender of this transaction has sent 5 transactions previously. It is an incremental value, so it goes up by 1 each time. So 0, 1, 2, 3, 4. Those are 4 transactions. It's different from a proof of work nonce. Just keep that in mind. I won't be describing proof of work nonce. That's an entirely different workshop, but just note that it's entirely different. And it also maintains the order of transactions, and order is very important inside the Ethereum network. Let me explain why. So here is how Ether works how to transfer Ether without a nonce. So Alice is on the left. Alice has 5 Ether and Bob has 0 Ether. Alice wants to transfer 4 Ether to Bob. Now Alice sends a transaction worth 4 Ether. Note that this is without a nonce value. Alice sends this transaction. This transaction gets accepted into what is called a transaction pool. Now, of course, there's more than just Alice's transaction. There's thousands and thousands of other transactions inside this pool. But to keep it simple, we'll only show Alice's transactions. So currently, Alice has 1 transaction processing in the pool. A miner can grab this transaction and validate it, which then gets updated throughout the network. Now, notice how Alice's Ether hasn't changed, and neither has Bob's, because the transaction hasn't been processed yet. It is currently processing within the pool. Let's say Alice decides, you know what, I want to send Bob another 2 Ether. Now, Alice can do that since she currently has 5 Ether still. So Alice is now sending 4 Ether to Bob, as well as an additional 2 Ether. Now, so something doesn't add up here. Looks like Alice is sending 6 Ether total. Of course, when I mentioned the order of transactions, now notice that again, it's without the nonce. Any one of these transactions can be processed first. So let's say a miner selects this transaction to be processed. This transaction is processed and 2 Ether is sent. Alice now has 3 Ether and Bob now has 2 Ether. Now let's say the second transaction is being processed. And oh no, Alice doesn't have enough Ether. Now the Ethereum network won't just reject this transaction. The transaction will actually stay inside the network. And anytime Alice gets 4 Ether, this transaction will be committed. Keep that in mind. So, and there's no way without a nonce that Alice can change this transaction. This transaction will always be pending. Now let's rewind. Remember how I mentioned that order doesn't matter in terms of without a nonce. So let's say the first transaction that we committed is being processed. So Alice is now sending 4 Ether to Bob. That transaction gets selected by a miner and is now being processed. So now Bob has 4 Ether and Alice now has 1 Ether. Now the second transaction is being processed where Alice is sending 2 Ether to Bob. And again, Alice doesn't have enough Ether. And again, this transaction still stays until Alice gets her 2 Ether. Now, why is this bad? Well, because Alice, in this case, it's undeterministic. We don't know if Alice is going to have 1 or 3 Ether, or if Bob is going to have 4 or 2 Ether. We don't know that. It's non-deterministic. And non-determinism in programming is pretty bad, especially when dealing with a whole consensus algorithm within the blockchain. We don't know how much Ether Alice is going to have and how much Ether Bob is going to have by the end of it. Now, let's see how Ether with nonce is sent. So same idea is that now Alice is sending Bob 4 Ether with a nonce of 1. This transaction gets added into the pool. And again, Alice sends another 2 Ether because that transaction hasn't been resolved. Alice still has 5 Ether. So now there are 2 transactions. But note the difference is that any time that there is a nonce value present, the lowest value nonce has to be passed first. It has to be executed first according to the Ethereum network's rules. You cannot, for example, execute nonce 2 before nonce 1. So it has to be in order. So this transaction is always selected first. And it always is processed first. Now, note this value. Now, Alice doesn't want to be sitting around with that pending transaction of 2 Ether. And remember how I mentioned that you weren't able to do anything without a nonce. But before we go over that, we'll just mention that, again, this transaction won't resolve because, again, she doesn't have the required amount of 2 Ether. Now, Alice doesn't want this sitting around. She doesn't want this transaction period. Instead, she wants to send the amount of Ether she currently has. So what she can do is that she can send another transaction with the same exact nonce in order to change the transaction. So notice that change from 2 to 1 Ether. Now this transaction is able to be processed. And now Bob has 5 Ether. And the transaction was successfully processed with no pending transactions for Alice. So that's the power of nonce. There is also an additional reason why nonce is very important. And I think it's more important than any other reason, is that it prevents a replay attack. Now, what's a replay attack? Well, let's see how a replay attack works without a nonce. Alice sends Bob 1 Ether. Note this is without a nonce. So currently, this is added to the pool of transactions that Alice is sending 1 Ether to Bob. This transaction gets resolved, and Bob, he looks a bit angry, mischievous. Bob received his 1 Ether, but in addition, he also captured that transaction that Alice has sent. He can replay that transaction over and over and over and over again until Alice no longer has any more Ether. Thankfully, we have nonce. Now, nonce guarantees that every transaction will be unique. So we send 1 Ether with a nonce of 1. This transaction gets resolved, and Bob, again, captures this transaction. He sends that same exact transaction with that same exact nonce. The Ethereum network detects this and says nonce 1 transaction has already been added into the blockchain and disallows any additional transactions of the same type. And Bob is rightfully so unhappy. So this is how a nonce prevents a replay attack. So why does it in fact prevent a replay attack? Well, because it makes every transaction unique. So what is a nonce? Well, it is the ID of a transaction. In this case, we are sending the 6th transaction because we start from 0. So 0, 1, 2, 3, 4, 5. So we sent 6 transactions. So this is our 6th transaction. What we learned what the transaction nonce is and why the transaction nonce is used. Do I have any questions before I move on?
Just one very quickly.
Sure.
Is the nonce associated to the sender, or it's just in the network like as the transactions get generated?
It is associated with the sender. So it's retrieved. The sender also has what is called an address nonce. So we are able to get that information from the sender. And that guarantees that the order of transactions is ordered. So yeah, it isn't generated, if that's what you're asking. Instead, it's calculated.